Okay, so today we're going to talk about a new form of measurement that's not new, but it's maybe new to you, called radians. You've probably heard of radians before because when you did geometry and we were working with circles and arc length, we were using degrees, and so we had you go into your calculator and switch maybe from radians and into degrees. Well, radians is actually a little bit more realistic and used in everyday life. Degrees are more made up in the sense that the ancient Greeks used the measurement of 360 degrees because they noticed that the sun was in the same position in the sky about every 360 degrees or every 360 days. And so they kind of made this relationship, well, if we're rotating around the sun and it takes 360 days, let's use that to measure a degree of rotation around a fixed point in a circular format. So degrees, we made them up, we sticked with them, but sometimes we need to work in radians because it's a little bit more realistic, and we need both. Okay, so the radian is an angle of rotation that is measured in terms of pi. Okay, so our formulas for circumference and area have to do with a radian. Angles of rotation can be measured in degrees or in radians. Essentially, what a radian is if we took a circle, I'm going to draw a circle over here. If I took a circle, and from that circle and in the center, I didn't mean to turn that red, I took the center of the circle and then I took a radius. Okay, so this is my radius. If I took that same radius and I bent it around a circle, so this is now of length r and this is of length r. This unit right here, the portion of the circle or the degree, the angle measurement theta is called 1 radian because I took a radius and I bent it around the circle. So theta can be a degree or it could be a radius or part of a radius, okay? So think of this as just a unit conversion. Sometimes we want to work in feet. But sometimes feet isn't good enough for us. Maybe we want to convert that into inches because we're not working with multiple feet. We're working with a smaller unit of measurement. So inches maybe would make more sense. We need to know how to go between feet and inches. Okay? The same thing can be true about degrees and radians and in radians to degrees. Okay? So what's going to happen is if I'm converting from degrees to radians, you're going to take your degree measurement, which is given in theta, okay, and I'm taking that theta degrees, and what you're going to do is you are going to multiply that by pi over 180 degrees, okay? The goal is to get the degrees units to cancel, and you would be left with a final answer in terms of pi. And your answer would be radians. Something pi radians. Okay? So pi is actually, the unit on that is radians. If I want to go from radians to degrees, we're going to do the reverse. So your theta is going to be given in terms of radians, and you would multiply that times 180 degrees over pi radians. And the goal would be to get, different color here, the radians to cancel, and you would be left with some unit in degrees remaining. Okay? So let's take a look at our quadrantal angles. So the 0 degree mark, that's our starting value here. If I took 0 degrees and I take 0, so we're converting into radians. So this is degree measure, so I'm going to use the first formula. 0 times pi over 180. Well, that's just going to be 0. So 0 degrees is equal to 0 radian. Okay? 90 degrees, we're taking 90 degrees times pi over 180. Well, that just becomes 90 pi over 180, and we can reduce that fraction. 90 and 180 reduce to be 1 pi over 2, or just pi over 2, because 90 is half of 180. So when I have 90 degrees, that's equal to pi over 2 radians. If I have 180 degrees times pi over 180, that's equal to 180 pi over 180, which is just pi. So 180 degrees over on the x-axis, 180 degrees, is equal to pi radians. Those are the equivalent. 270, so we're taking 270 times pi over 180 is equal to 270 pi over 180, and those are all divisible by 90. So we end up getting 3 pi over 2. So if I took 270 divided by pi, I would get 3 pi over 2, or 270 divided by 180. So this 270 degrees is equal to 3 pi over 2. And so if I look at 360 degrees, a full circle, times pi over 180, we get 360 pi over 180. 360 divided by 180 is just 2 pi. So then when I come back here, 360 degrees is equal to 2 pi radians. Now, we just did a full circle. So we took, I'm going to draw a circle here. Maybe. Draw my circle. I don't get a circle. Oh, I got a circle. That's not what I wanted, though. There we go. I'm going to take that. Center it as best as I can. That's pretty close. Okay, so if I took an initial ray and I went one full rotation, that's a 360 rotation, or 2 pi radians. Well, notice that's 2 pi radians. And a radian is just a radius. That's circumference. And so that's where the formula for circumference comes into play. Because we're talking about the relationship between the radius of a circle and the rotation around the circle. Okay? All right. So then convert each degree measure to radians. Give your answers in terms of pi. So here is where, and this is it for our lesson. So we're going to take 30 degrees and convert that into radians. So we're going to take, since I want the degrees to cancel, degrees goes in the bottom. So I'm going to do 30 degrees times pi over 180. I'm sorry, that's so small. Let's give us a little bit more space. So you can use your calculator in this one and quit out of here. So I am taking 30, don't do the pi. So it's 30 pi over 180, which really is just 30 over 180, and I just want that in fractional form. So this is 1/6. So if I have 30 pi over 180, if I reduce the fraction, that's just pi over 6. So this is your final answer. 45 degrees. I can make this smaller now. 45 times pi over 180. 45 pi over 180 is equal to, well, if I take 45 divided by 180, and then math fraction, it's just 1/4. So this is pi over 4. Okay, and then 120, so 120 times pi over 180 is 120 pi over 180. Now let's just do this one without a calculator. 60 divides into both 120 and 180. So this is 2 pi over 3. Okay, you're going to learn to memorize these because we will talk about them a lot. Now, if I want to go the other way, converting each radian measure to degrees, so now I'm going to take 3 pi over 4, and I'm going to multiply that by 180 over pi. Since I want pi to cancel, that's ultimately my goal. So pi's gone, pi's gone. So now I need to reduce, and so 3 times 180 is 540 divided by 4. And so if I divide that, that's going to give you your degree measure. 540 divided by 4, and we get 135. So this is 135 degrees. Okay, if I take 7 pi over 36, which is an angle measure, it's just in radians, times 180 over pi, because I want pi to cancel. So put pi on the bottom because I have a pi in the top. I can't divide this as easily. So we're taking 7 times 180, or 180 times 7. And then I'm going to divide that by 36. 35 degrees. So this was 1260 over 36, which is 35 degrees. Okay, and then pi over 2, we actually did pi over 2. Pi over 2 was one of the quadrantal angles. But if I times or multiply by 180 over pi, pi cancels, 180 over 2 is just 90 degrees. Okay, so easy conversions. You guys got this, right? All right.